Hello, we are discussing about GATE 2005 ECE paper. Look at the circuit shown. It's a simple RC circuit, and for that one input is a square pulse of 3 volts with duration of 2 seconds, and the capacitor is initially uncharged. Find the output voltage V0 at t is equal to 2 seconds. Okay. So this is the input voltage given. So how do you define this input voltage? Vi is equal to 3 volts. Okay, during t is going to be greater than or equal to 0 to t is less than 2 seconds. So you can say it as t is less than 2 minus seconds. 2 minus seconds is nothing but just before 2 seconds. Remember that one. And Vi is equal to 0 volts for t greater than 2 plus seconds, greater than or equal to 2 plus seconds. Very important, because at t is equal to 2 seconds, can you able to say what is input voltage? At t is equal to 2 seconds, can you able to find the input voltage? If you are looking at this point, this is also related to 2 seconds, but it is giving 3 volts. If you are looking at this point, this is related to 2 seconds, but it is giving 0 volts. Okay, so you can say that one as time is progressing in the right side, so we can say time is progressing towards this way. This is comes first and this comes later. So this will be taken as 2 minus and it will be taken as 2 plus seconds. Just before 2 seconds, just after 2 seconds. So just before 2 seconds 3 volts, just after 2 seconds 0 volts. Okay, now we can say during 0 to 2 minus seconds, okay, that is around 2 seconds, you are applying a constant voltage of 3 volts for this circuit. Okay, and by that time, whenever you are applying a voltage for this RC circuit, capacitor gets charged. Since you are applying during, first you are going for the during 0 to 2 minus, during 0 to 2 minus, okay, you are applying the voltage of 3 volts. So plus minus 3 volts we are applying. As you are applying 3 volts, current flows in this direction. So I is the current. Whenever current enters into the capacitor, capacitor gets charged. Okay, and capacitor charges with respect to time constant. Capacitor charges exponentially with respect to time constant tau. Tau is the product of R and C, since the circuit is consisting of single resistor and single capacitor. That R and C is nothing but 1K multiplying with 0.1 microfarad. So this is 1 into 10 power 3 into 0.1 into 10 power minus 6. That means 0.1 into 10 power minus 3. 0.1 can be written as 10 power minus 1 into 10 power minus 3, which is 10 power minus 4 seconds, or 0.1 milliseconds. Tau is equal to 0.1 milliseconds. And remember that one, voltage across a capacitor while charging is defined like this: Vc of t is equal to V into 1 minus e power minus t by tau. At t is equal to tau itself, then Vc of t is equal to 0.693 V. 0.693 V. 0.693 V means 69.3% of final voltage is reached within one time constant. As time increases, if t is 2 tau, that is 2 time constants are completed, 3 time constants are completed, 4 times, 5 time constants. So as time progresses, capacitor reaches towards final value. Okay, so generally in practice, capacitor reaches final value of applied voltage in minimum of 5 time constants. If you are allowing the capacitor for 5 time constants of time, then capacitor can reach the final value what it is applied. Okay, then capacitor reaches steady state. Then C attains steady state where it acts as open circuit. So time constant is 0.1 milliseconds after 5 time constants. After 5 time constants, that means at t is equal to 5 tau, which means 0.5 milliseconds. After 0.5 milliseconds, capacitor voltage will be equal to 3 volts. It will reach the 3 volts and acts as open circuit. So the circuit is now looking like V0 of t with 3 volts present over here plus minus and 3 volts you are applying over here. V0 of t will become 0 volts because entire voltage applied 3 volts is taken by the capacitor. No voltage is present across resistor. Otherwise you can think in this way. Since it is acting as open circuit, no current flows. No current flows means no voltage drop across resistance R. So output voltage is 0 volts. Okay. Now what happens? At t is equal to 2 seconds. By the time reaching t reaches 0.5 milliseconds, capacitor voltage is 3 volts. Now what is the capacitor output voltage at t is equal to 2 seconds? That you are going to check. Okay. Look at this one. This is Vi. 3 volts is applied till 2 seconds. Okay, and whenever time constant is reaches 0.5 milliseconds, capacitor voltage is reaching the final value. Okay, so capacitor reaches exponentially like this. So capacitor reaches exponentially and this is the capacitor voltage till this point. This red color is related to Vc of t. And for a simple RC circuit given V0, this is Vc, this is Vi. So V0 can be written as Vi minus Vc. So as capacitor voltage, input voltage is constant 3 minus Vc is going to be increasing. That means V0 has to decrease. Whenever Vc reaches 3 volts, V0 has to reach 0 volts because 3 minus 3 becomes 0. So then the equation is going to be, then the output equation is going to be like this. This is V0 of t. Okay, now here comes the important situation. At t is equal to 2 plus Vi is going to be 0 volts. But voltage across capacitor doesn't change instantaneously. Voltage across capacitor doesn't change instantaneously. So that Vc at t is equal to 2 minus is same as Vc at 2 plus. Vc at 2 minus is nothing but this value. Vc at 2 minus is 3 volts. So this will be 3 volts itself. Vi is 0 at t is equal to 2 plus. Capacitor voltage at 2 plus is same as capacitor voltage at 2 minus, which is 3 volts. Now we are going to calculate V0 at 2 plus. Output voltage. V0 at 2 plus is equal to, from this equation, okay, V0 at 2 plus is equal to Vi at 2 plus minus Vc at 2 plus. So V0 at 2 plus, Vi at 2 plus is 0 volts. 0 minus Vc of 2 plus is 3 volts. So the answer is 3 volts. So as the input is changes by, look at this one, input is changing by Vi is reduces by 3 volts. This reduction in 3 volts, Vi is reduced by 3 volts, but voltage across capacitor is not changing. Where this decrease should come? This decrease should come at the output voltage. Okay, so V0 decreases by the same voltage as capacitor opposes instantaneous changes. At t is equal to 2 seconds, instantaneous change is taking place. Okay, input voltage is dropping by 3 volts. So that drop is taken by the output. It is not taken by the capacitor, as capacitor opposes any instantaneous changes in the voltage across it. So now the output voltage can be drawn like this. Output voltage can be drawn, okay, in this way. This is minus 3 volts, and afterwards as time progresses you are applying 0 volts. So capacitor discharges to 0 volts. Capacitor discharges to 0 volts, okay. Through the same time constant, to discharge entirely it requires 0.5 milliseconds, so that it will be taken as 2.5 milliseconds. By the time it reaches 2.5 milliseconds, capacitor discharges to 0 volts, so that output voltage is going to be reaching the 0 volts by that time. So now this is V0 of t and it is VR of t, Vc of t. This is V0 of t. So output voltage at t is equal to 2 seconds is minus 3 volts. Output voltage at t is equal to 2 plus seconds is minus 3 volts. So the right answer for this question is B. B is the right answer.